Hi, welcome to Parametric House. In this Grasshopper tutorial, I want to show you how you can make a series of circles on a closed planar curve. So as you can see here, if I change this curve, this is going to update. I can change the radius here and reset the simulation with the kangaroo plugin, and also change the number of circles I want. And as I increase these circles radiuses, they're going to make a circle packing pattern. And then I can also change the multiplication to change their location. You can see that I have also produced this on another closed curve, so I can also change that and produce different results. We are also going to talk about collision and find those circles that are out of our boundary and delete them, and then find the final results. Okay, let's get started from scratch. First, what I want to do here is to draw a curve. It can be a NURBS curve or a polyline, doesn't really matter. And because I want to make this in any plane, I'm going to bring this up and rotate it a little bit. So you can see that this is in a different plane than XY or XZ or YZ. Okay, let's bring this into Grasshopper. I'm going to go to the params menu and hit the curve, set one curve, and bring this into Grasshopper. If you don't want to mess with this curve, you can right click and internalize, and this will not affect the input, as you can see here, or we can just put it to set. So whenever we update the curve, this is also going to be updated. Be sure that the curve is planar. So we're going to only talk about planar curves. Okay, after we have imported the curve in Grasshopper, I'm going to make an offset from the curve by going to the curve and utility offset. Why I'm doing this is because, let's just give this a number slider for the distance. And if you run into problems, remember to give the curve also to the plane so it finds the plane. So be sure to give a planar curve. This has to go inwards, and the reason I'm using this distance expression minus x to go inwards is because I want to produce those random points inside a little bit of an offset from the boundary. This is going to help me to control the circles and the circle packing, and also have a little bit of a border around the base curve. Okay, after you have defined the offset, we have to make it a surface. So I'm going to go to the params menu, geometry, and give it a surface. That's going to easily convert that into a surface because it's planar. If it's not, it's going to give you an error. Then I'm going to go to the vector grid, and this populate geometry tool is going to help you to produce random points on the surface. So I'm going to just give that to the surface and just define how many number of points I need. That's going to be the number of circles. For example, it's like 3 to 100. And give it to the count. You can see by increasing that, the number of the points is increasing. And this is a complete unique situation because you can see that these 3 points, when I increase them and go back to 3, it's again at the same position. If you want to produce a new position each time, you just have to give a number slider maybe between 1 to 1 million, whatever number of different situations you want to produce, and give it to the seed, which is going to be the engine. So if I change that, you can see that it's going to give you different results. Okay, that's a helpful tool to get started with the first points. And now what we want to do is to produce those, just take a look at the circles and what's happening. So what I want to do here is to make a plane for this. What I usually do is to go to the params menu, geometry, and give a plane to a curve, especially if it's a planar curve, because that's going to simply give you the plane of the curve. That's really easy. And then we can just go to vector, a plane, and use this plane origin to bring those points to this plane. So you can say plane origin, the base plane is this one, and the origin of the points is this one. And if I just turn everything off and only the planes on, you can see that I'm having the plane of those points. That's important because we're going to go to the curve circle and see those circles in that plane. And if I just give this a number slider between maybe 1 to 30 with 2 decimals, that's the radius, I can see what are the circle radiuses here, and we're going to find their intersection when we increase the circle radius. So be sure to give it a plane, and as you can see here, this is inside the curve plane. Okay, now we're going to use the Kangaroo plugin to give them some collision. So we're going to go to the Kangaroo main and use the Kangaroo solver to use the circle packing technique.